Good afternoon, friends. In last lecture, I have discussed the moist heat sterilization. In that, first it's autoclaving, then tyndalization and pasteurization. Today, we will see the next point, that is radiation sterilization. In that, first by ionization radiation, and second, that is by non-ionizing radiation. Yes, so the radiation sterilization, this method involves the exposing the packed material to the radiation for sterilization. It means what? The material which is to be sterilized, which is exposed in packed material, so which is exposed, or they expose the packed material to the radiation. That is nothing but the radiation sterilization. There are two types of radiation sterilization. First, that is ionic radiation, and second, non-ionic radiation. Yes, there are basic two types of radiation. First, that is ionic radiation, and second, non-ionic radiation. In that, first we will see one by one. First, ionizing radiation, and second, non-ionizing radiation. In that, first, the ionizing radiation, they are powerful radiation and very useful for sterilization. Yes, the ionizing radiation, it is very powerful radiation and which are used for, or which is very useful for sterilization. In the ionizing radiation, sterilization, the operator needs to protect himself from what? From exposure from this radiation by use of unique clothing, for example X-rays or gamma rays. Then we will see the principle of this radiation. The ionizing and non-ionizing radiations are the two common types of radiation which are used for what? Yes, which are used for what? That is sterilization. The ionizing radiation, yes, the ionizing radiation uses the radiation of short wavelength and high intensity. The ionizing radiation, in ionizing radiation, there is use of radiation of short wavelength and high intensity to destroy the microbes. For example, gamma or X-rays react with cellular DNA and thus damage it. And in case of non-ionizing radiation, there is use of radiation of longer wavelength and lower intensity. Keep in mind the difference between this principle of ionizing and non-ionizing radiation. Yes, in ionizing radiation, there is use of radiation of short wavelength and high intensity. And in case of non-ionizing radiation, the uses of radiation of longer wavelength and lower density, and thus they fail to penetrate the substance effectively and are limited to surface sterilization only. For example, UV light. Yes, I am repeating the non-ionizing radiation. The non-ionizing radiation uses the radiation of what? The longer wavelength and lower intensity, and thus they fails to penetrate the substance effectively and are limited to, and it is only limited to surface sterilization only. For example, UV light. Then we will see the procedure. First, in ionizing radiation, first gamma ray sterilization, then second X-ray sterilization, then electron acceptor, then electron accelerator, then microwave linear accelerator. Yes, in ionizing radiation, first that is gamma ray sterilization, then second X-ray sterilization, next electron accelerator, then electron accelerator, first that is electron accelerator, and second microwave linear accelerator. We see one by one. In that, first the gamma ray sterilization. In this sterilization, the cobalt 60 isotopes is used as a source of gamma rays. Yes, in gamma ray sterilization, the cobalt 60 cobalt 60 isotope is used as a source of gamma rays. The ionizing radiation, it produces the disruption in subatomic particles which are involved in the formation of microorganisms. Yes, the ionizing radiations, what it produces disruption in subatomic particles which are involved in what, the formation of microorganisms. Then simply this radiation, it causes the damage to the genetic material, that is DNA or RNA of the cell. Yes, this gamma ray sterilization is damage to the genetic material, that is DNA or RNA of the cell. If the DNA or the RNA of the microorganism is damaged, the cell will die. Yes, what I am saying, if the DNA or the RNA, that is genetic material of the microorganism, is damaged, then cell will die. Or in another word, the radiation is damage to the hard drive of a bacterium. Yes, that is why it is saying hard drive, because it damage to the DNA and RNA. After that, if the RNA or if the genetic material, that is DNA or RNA, is damaged, then the cell will die. Therefore, it is called as the radiation. This radiation, it causes or it damage to the hard drive. Yes, second, that is X-ray sterilization. Yes, in X-ray sterilization, the combination of shorter exposure time and improved dose uniformity ratio, okay, that is capital DUR. The combination of shorter exposure time and improved dose uniformity ratio makes the X-ray sterilization in a viable processing option for a variety of products. The similar electron beam X-ray processing is powered by the electricity. Then, due to the reduced processing time, it leads time are improved for maintaining good and penetration capability. Then, the adverse effect on products are reduced due to the reduction in processing or the reduction in the exposure time. Yes, the adverse effect on products are reduced due to what? Due to the reduction of exposure time or the reduction of processing or the reduction in processing time. Next, that is electron accelerator. In this method, the high energy electron beams are generated. Yes, in this method, the high energy electron beams are generated due to the acceleration of electron from a hot filament. Yes, in this method, the high energy electron beams are generated due to the acceleration of electron from what? From a hot filament down a evacuated tube under high potential difference. After this, the additional energy is imparted to this beam in a pulse manner by a synchronized traveling microwave. Then there are two types of electron accelerator apparatus are available. First, electron accelerator. Yes, it produces the electron with maximum energy, that is 5 megavolt. Then microwave linear accelerator. Second apparatus, that is microwave linear accelerator. It produces the electron with maximum energy, that is 10 megavolt. Then the high energy electrons have better penetration power, but there is a risk of induced radiation. Yes, what I am saying, the high energy electrons have a better penetration power, but there is a risk of induced radiation. In that, the article which is to be sterilized are arranged on a horizontal conveyor belt and are radiated from one or both sides. Yes, in this microwave linear accelerator, the article to be sterilized are arranged on a horizontal conveyor belt and are radiated from one or both sides. Then this is all about what? Ionizing radiation. Second, that is non-ionizing radiation. Yes, this non-ionizing radiation is safe to the operator for sterilization. and they are like a ultra UV ultraviolet radiation. They can be used even at the door entrance to prevent the entry of live microbes in the air. That first infrared radiation and second ultraviolet radiation. Yes, in non-ionizing radiation there is use of two rays. First, that is infrared radiation, and second ultraviolet radiation. First, in infrared radiation, the infrared that lies in the waveband range of 0.8 to 15. It can be easily generated. Then, with the help of absorbent surface, they are changed into a sensible heat, producing high level of increasing the temperature, the energy attack on the surface, and which is changeable into heat and depend upon the same geometric condition as that of the UV lights. So the infrared radiation is the best to apply to an even and smooth surface with vertical radiations. These infrared have been used to fix the internal phase of aluminum lead. Yes, these infrareds have been used to fix the internal phase of aluminum lead with a plastic coating on the external surface. Then, since the temperature increases, can cause the plastic to soften. The maximum exposure time and the temperature are limited. Next, that is ultraviolet radiation. This radiation with wavelength of This radiation with the wavelength of 240 to 280 nanometer are lethal and have some bactericidal activity. The UV radiation denature the bacterial protein and also disrupt the replication of bacterial DNA. Next, we will see the merits. That first, terminal processing. Due to the penetration, the depth of ionizing radiation and products can be processed in their fully sealed final packaging, and this limits the risk of contamination following the sterilization. Then second, cold method or the cold temperature independence. The temperature increases during the treatment are minimal, and the radiation sterilization has no heat dependence and is efficient at both ambient temperature and sub-zero temperature. Then second merit, it is compatible with temperature sensitive material. Yes, it is compatible with temperature sensitive materials such as pharmaceuticals and biological samples. Next merit, chemical independence. No volatile or the toxic chemicals are needed. It means it does not depend upon the any volatile or the toxic chemicals. In case of X-ray or E-beam irradiation, no end products requiring disposal are generated during the procedure. Next, the merit, no residue. The radiation leaves no residue on the sterilized product. Next merit, flexibility. The radiation can sterilize product of any phase, for example gas, liquid or any solid phase. Products with a variable density, then variable size or the variable thickness, and the homogeneous and also the heterogeneous system. Yes, what I am saying, the radiation can sterilize product of any phase, for example gas, liquid or solid material product with variable density, with variable size or variable thickness, and also sterilized the homogeneous and heterogeneous system. Then the sterilization can be conducted at any temperature or the any pressure. The sterilization it can be conducted at any temperature or the any pressure. Then next merit, time efficiency. E-beam sterilization can be completed within second to minute. The E-beam sterilization can be completed within a second or the minute, second to a minute. Then next, sterilization assurance level, that is SAL, capital SAL, sterility assurance level. The radiation treatment can yield high SAL, that is 10 to 6 or a better, and it ensures that less than 1 out of a million microorganisms survive the sterilization process. The next merit, that is age. Only a single variable, the exposure dose of the exposure time must be monitored. Yes, only a single variable, that the exposure time of the exposure dose is must be monitored, making radiation sterilization is simple, and it is very simple, and second, that is easy, it is very easy to control. Then we will see the demerits. First, that is instrumentation. In that, the capital costs are high and specialized facilities are often needed. Then the gamma radiation, it requires nuclear reactor, and E-beam or the X-ray radiation are generated using the electron beam accelerator. That is demerits of this sterilization, that is instrumentation. And second, product degeneration. The radiation based methods are not compatible with all material and can cause a breakdown of the packaging material of the packaging products. Yes, it causes what? Breakdown of the material. Then the common plastics such as PVC, that is polyvinyl chloride. Then PTFE, that is polytetrafluoroethylene, are sensitive to the gamma radiation. PVC and PTFE are sensitive to the gamma radiation. The high energies involved in E-beam radiation and also lead to main chain session, that is breaking of a long chain backbone, and the chemical cross-linking of packaging polymers, that is product degradation. Next, that is radioactive material. When the gamma radiation is used as an ionization source, then the gamma radiations is used as an ionization source, the radiation sterilization, it requires handling and the disposal of radioactive material. Note that the commonly used radioactive levels irradiation with gamma rays does not induce the radioactivity in the treated sample itself. So this is all about the merits and demerits of this sterilization. Next, we will see the application. First application, the sterilization through the radiation by using high energy gamma rays or the accelerated electron is proved to be a very useful method for a industrial sterilization of heat sensitive material. Yes, it means this radiation sterilization, it is very important method of sterilization in industrial sterilization of what? The heat sensitive products. Second application, the radiation sterilization is usually performed to an article in a dry condition, including what? The sutures, then surgical instrument, then unit dose ointment, then plastic syringes and other dry pharmaceuticals. Yes, it means the radiation sterilization is useful for sterilization of sutures, then sterilization of surgical instrument, then sterilization of unit dose ointment. Next, the sterilization of plastic syringes and the sterilization of other dry pharmaceutical products. Next, the deposit of the next, the ionizing radiation is suitable for sterilizing the heat sensitive pharmaceuticals. Yes, this ionizing radiation is useful for sterilization of heat sensitive pharmaceuticals. For example, antibiotics, swabs, then plastic, then disposable items, then hormones and vitamins. Then cobalt 60 is mostly commonly used as a source of what? That is source of gamma radiation, and which is used to sterilize the animal feeds, then sterilization of antibiotics, sterilization of hormones, sterilization of sutures, then sterilization of metal foils, and that is sterilization of plastic disposables. Then next application, this the method has also been has used to sterilize the pasteurized meat and other food items. Yes, it is useful for sterilization of pasteurized meat and other food items. Next application, the non-ionizing radiation is useful or used for the sterilization of closed area, then incubation hoods. Yes, for sterilization of, or it is useful for sterilization of closed areas, then incubation hoods, laminar flows, operation theaters, then sterilization of microbiology laboratory. So this is all about what the ionizing radiation, that is the ionic radiation and also the non-ionic radiation. Next part, that is chemical method of sterilization. In chemical method of sterilization, first that is sterilization by heating with bactericide, and second that is gaseous sterilization. In chemical method of sterilization there are two sub methods. First that is sterilization by heating with bactericide, and second that is gaseous sterilization. Yes, what is chemical sterilization? The chemical sterilization is a reliable method but has its challenge, which includes that the sterilant may react with polymer being a sterilized, and the residual chemical may exert toxic effect on the products and the operator safety associated with exposure to the sterilant. There are two sub-methods used in chemical method of sterilization. First, sterilization by heating with bactericides, and second, that is gaseous sterilization. First, we will see the sterilization by heating with bactericide. This method may be used for sterilizing the aqueous preparation which are unstable at high temperature attained in the moist heat sterilization process. Yes, this method it means this sterilization by heating with bactericide. This method may be used for sterilization of aqueous preparations which are unstable at higher temperature attained in the moist heat sterilization process. Then the method has lower margin of safety and it should be used only when moist heat sterilization is not applicable. When this method is used, if the moist heat sterilization is not applicable, then and then only this method is used. In this process, the medicament is dissolved or suspended in a suitable solution. Yes, in this method, the medicament is suspended or dissolved in a suitable solution of a bactericide so as to achieve the concentration of bactericides. First, bactericide for injection, in that first chlorocresol having concentration 0.2% weight by volume, and polymercuric acetate or the polymercuric nitrate having the concentration 0.2% weight by volume. So this is the bactericide for injection. Yes, first chlorocresol having concentration 0.2% weight by volume, and phenyl mercuric acetate or the phenyl mercuric nitrate, that is having concentration 0.2% weight by volume. Next, the bactericide for eye drops, in that first benzalkonium chloride having concentration 0.01% weight by volume. Then second polymercuric acetate, phenyl mercuric acetate or the phenyl mercuric nitrate having the concentration 0.002% weight by volume. Then thiomersal having the concentration 0.01% weight by volume. Then chlorohexidine acetate having the concentration 0.01% weight by volume. These are the bactericides and their concentration. User for what? Bactericide for injection and bactericides for eye drops. Then the preparation is then transferred into a final container which is then sealed so as to exclude the microorganisms and heated at 98 to 100 degrees Celsius for a 30 minutes by heating in a boiling water bath. This bactericide should possess the following properties or the ideal properties. That is, first, it should be, that is the bactericide, it should be non-toxic. Then it should be compatible with medicament. Then the stable and active at it should be stable and it should be active at a various pH. Then it should be stable during heating and also it should be stable during the storage. These are the few properties of bactericide. And the lethal effect of bactericide increases with the rise of temperature. Then we will see the application of the sterilization. First, the method is used for sterilization of injection, which the reasonably thermostable and do show some evidence of deterioration when heated at 115 to 116 degrees Celsius for 30 minutes, that is autoclaving. And second application, the method cannot be used for sterilization of injection, mean for intrathecal or the peridural administration. Yes, what I am saying, keep in mind, this method is or the method cannot be used for sterilization of injection, mean for intrathecal or the peridural administration. And similarly, this method is not suitable for intravenous injections when a single dose exceeds 50 ml. Yes, similarly, this method is not suitable for intravenous injection when the single dose exceeds 50 ml, that is 15 ml. So this is all about the sterilization by heating with bactericide. Next point, that is gaseous sterilization. This point we will see in next lecture, or the remaining part we will see in next lecture.